Here's a group of Hillside Foundation examples for education videos. In this video, I am going to provide you with a few construction methods you can use to form a step-down footing on the side of a hillside. However, before I do that, I want to start with a regular foundation, raised foundation, couple of stem walls here, and how it's formed. So let's go ahead and remove the concrete and then take a look at the forms. And I'm going to assume that most of you watching this video know that the top of the forms around the entire perimeter need to be level. And for those of you wondering just why in the heck I'm starting with something like this, it's just to break it down and see if I can make it a little easier for those of you who might be having a difficult time figuring out where you're going to start. And as we can see here, for our 20-foot by 20-foot building, if you have a 5-degree slope, you might not need to step the footings down. However, if we double the slope to 10 degrees and we think we can save a few dollars on the concrete, then we might want to step the footing down. So again, level all the way across. The forms on something like this are going to need to be level. And you're probably going to start from a point at either end, and that would either be this side or this side. However, you can start laying out the foundation from this side, depending upon your project and the property. And in our example, we are going to start from this side here and work our way towards the front. And that would look something like this if we were going to step it down once in the middle in order to reduce this amount of concrete and replace it with wood-framed walls to create a level floor. And here you can see where we took the front section or the front form boards and just simply lowered it to where the bottom of the form touches the ground. So here we have stepped down the front area, and here's what it would look like on the foundation. And of course, this step down only has one section where we're stepping down, and the total height that we're stepping down is 1 foot 9 inches. However, if we only step this down once, we're still going to be pouring a lot of concrete that we might not need to. And like I said, you can either start from the top or the bottom. And if you are going to start from the bottom, you will basically be reverse engineering the construction methods and the process that I will be going through in the videos. So we are going to start by creating a level, straight upper form board that will provide us with the exact location of the front of the building. And once we have it firmly secured, everything is staked off, and we know for a fact it's straight and level, we can go ahead and get started on our level guide boards. And even though I'm going to be using smaller lumber, if you have access to larger lumber, then feel free to use it. Our building is going to be 20 foot long. If you have a 22-foot long 2x4, 2x6 that's straight, then I would suggest using that instead of piecing this together like we're going to do here. So in order to create a guide board that is not going to be in our way, I would suggest coming in about 2 or 3 feet and then squaring the guide board to the front form. And a framing square might provide you with an excellent place to start. So you can just simply grab the framing square and line it up like this. And then of course I do have other videos on how to square something, and I will put links to those in the video comment area. So again, our guide board is going to need to be level and square and out of our way. For example, if we put it at the edge of the building, it could be in the way of our form boards. However, if you don't think it's going to be in the way, feel free to put it wherever you want it to be. And of course, after we have this one firmly secured and level and square, we can add the next piece, along with any braces or screws or nails that we are going to use to prevent it from moving. So after you've secured everything and checked it for square, you can measure the length of the building. For example, ours is going to be 20 foot. We're going to measure 20 foot from the inside of this form board to the inside of the form board on the other side. and make sure that you put an X on whatever side you need, or right on it, right here. Just grab a pencil and write, this is the side we're going to put the form on. And do that throughout the rest of the project. If you make one simple mistake like this, to where you locate something on the wrong side and then start pulling measurements from it, then you're going to be tearing stuff apart and putting it back together. And in some instances, that could be a lot of hours. Next up, let's install a vertical board here. And this is going to need to be plumb or vertically level in both directions. So put the level on this side and then put it on the face of the stake also, because we're going to be pulling measurements from it to locate the end form boards. And with that said, let's go ahead and zoom out and see what we have here so far. And if you are following my example here and you staggered the board, you connected this one together, and you are not using a solid piece of wood for your guide board, then it would probably be a pretty good idea to nail a block on the side of your guide board so that everything lines up here. This is something else that could goof you up. So make sure that you're using the same line and it's continuing straight through. And if the building is less than 20 feet long and you can get 20-foot long lumber, then you might want to get it to use it for your guide board so that you don't end up with this problem. Next up, let's go ahead and grab the level and then plumb down or level down so that we can make a mark on the form to use as a marker so that we can locate the end of the form boards. And to do that, we're simply going to measure over 16 feet. Now you can measure all the way over to the end instead of doing it this way, but in this example, we're going to use 16 feet as a way of centering everything. And of course, we are going to do the same on the other side. And these are the points we're going to use to double check everything by cross measuring and fine tuning everything here. So we're simply going to measure from the inside of the form to the inside of the form. And we're going to do that on both sides. And then after that, we are going to measure from the point here to the point here, and from this point to this point here, in order to make sure everything is square. So again, from the inside point here to the inside point here, and on the other side, inside point and the inside point here. So you got a good idea where we're measuring from. And if everything is right on the money, then you're going to have a square building. And I say that, but again, if these boards are not perfectly level, then these measurements could be off a little bit. And after we have figured out which lines we are going to use, we can go ahead and measure over to the end of our form boards on both sides to locate the end form boards. And of course, we do the same thing over here. If you remember earlier in the video, we measured from here to here at 2 feet and then attached our guide board. And then, of course, we would need to transfer this measurement also. And this is where we can't get messed up. We got to remember what side we're coming off of. So take the time to double check all of these measurements and the locations here. And to calculate the measurement, we are going to be stepping down the concrete forms. We can divide that number, which we're going to be stepping down 4 times, into 3'6" and 5/16. So again, we're coming off of the top of the form, which is going to be the bottom of our guide board, and measuring to the top of the form. And then once we have that measurement, we can start setting our form boards. Now keep in mind that the length of these boards can be a little bit longer or shorter if needed. And if you have a measurement that might be off a little bit, then you can always have that at the bottom. So here we're going to have 10.5, 10.5, 10.5, and then 10 13/16 instead of 10 1/8, 10 1/8, 10 1/8, and maybe 10 1/4. So again, the lengths can vary. And the difference in height can vary also, just as long as it all adds up to the same number. So here we have 5 feet from the inside and then a 10.5 inch drop. Now I went ahead and I ripped the boards down to 10.5 inches to make it easier in our example. Now you don't have to do that because you could always use 2x10s that were going to be 9.5 inches and then adjust the last one here if that's going to make it easier on your project. And I hope I'm not confusing anyone here, because sometimes you might have shear panel or some type of structural details that will require some of these boards to be longer and smaller. And here's an example of what I'm talking about if I'm going to use a couple of 2x12s. I'm going to use a 2x12 here that's 11.5 inches tall, and then use them on the next two, and on the last board I will make it a little shorter. And I would imagine that this is what most concrete form workers are going to do to make their job a little easier. And with that done, we can finish forming, and this might make a little more sense because we're running the boards through here instead of ripping them down or cutting notches in them or whatever it would take to make this 10.5 inches. And even though we can leave this form board off and stop the footing back here, I'm going to finish this off by raising this up and only having 3 step downs instead of 4. Again, we can have 4 step downs, and then this would step down about here, and then you would have a wall that would sit on top of this footing, and then a wall that would be a different height sitting on top of this one, and this one. So again, in my effort to provide you with a few more examples in one video, we're going to finish it off like this. And here's what it would look like after we finished forming it. Of course, you'd still have to drive all of your stakes in and install all of your bracing. In this video, I will be providing you with some design information. I'm going to show you a couple of different ways that you can build a foundation for a house on a sloping hillside or a sloping property. So let's go ahead and get started with our first design. And you can see here where it is stepping up gradually. I have divided the walls here into 4 equal sections. And of course I have the top plates sitting on top of the treated lumber, the top plates. And of course your joist would sit on top of these plates here. Everything would be nice and flat. So we have here a minimum of 6 inches. You would need to check with your local building department to verify what they might actually require. And out here in Southern California, 6 inches is the norm. And you can see here where it is divided into 4 spots. So each one of these walls, each one of these sections are the same length. And of course you got to make sure that you're going to, whatever you do, you're going to be at least 6 inches, whatever the minimum distance is here also, as well as here. Going to need an access opening into the crawl space area. Anchor bolts. At every break, you're going to need to have anchor bolts, usually within 12 inches of the breaks, and 12 inches from the corners. And of course, whatever the anchor bolt spacing here, I believe this was 20 foot. So these are about 5 feet and 5 feet lengths here. And the anchor bolts usually need to be no more than 6 feet apart. So 2 would probably be fine for a situation like this. Same all the way up. And you can see here where we have the breaks. In between the breaks, you're going to need to have at least 4 feet. Common construction method for framing walls. And I wanted to give you an idea what you would do to attach the framing plate to the treated lumber when you have an anchor bolt in the way. And if that's the case, you might need to notch out the bottom of the top plate here, that is so that it fits over the anchor bolts. So just thought I would throw that out there. So again, a step down footing with our framing plates, 4 foot minimum, basically in length, and they need to be at least 4 feet away from the breaks. And of course here, it doesn't really matter you can, these are going to be bolted to the foundation. It's not going to be exactly the same as if you have a framing plate with framing studs underneath them. These are going to be bolted. This is basically a solid connection here, and you're putting the wood on top. You could actually just have this brake line up with this brake, and it wouldn't be a problem most of the time. So this is probably the most common method. This is the way I would do it if I could build something like this to save time and money in forming all of the concrete. You're going to save money in pouring, in the cost of the concrete and the rebar, labor, time, materials, you name it, and you're still going to get a nice foundation with something like this. Now, in our second example, I'm going to lower this wall here, or the foundation, a little bit lower. Before, if you remember, we had it even with the top of this stem wall here, and just kind of throwing it out here another way if you want to save a few more dollars. And I also want to point out the two different corners, if we can focus on. I framed them or built them differently. So on this one here, we have the sloping surface, and it's going all the way to the corner. So, this has got to be 6 inches here, but this kind of provides us with some protection of the, if we get snow or something that built up against the corner here, then we're going to have a little more concrete, and the wall goes all the way to the corner. And I just kind of showed you how I would frame it here. Put some treated lumber up here, run a block across here. Give you another view of it. Of course, the studs are going to be longer. The opening does not need to be this tall. I think the minimum access is 22.5 by 22.5 for something like, for a crawl space. It might be 30 by 30. But again, you got to check with your local building department. Get a view of this one from the outside. And you can see here where we brought the foundation back a little bit. And of course, over here it ran past the lower wall. And here you can see what I'm talking about. And as long as we're going to have our 6 inches, our minimum space here, this shouldn't be a problem. Something else you're going to need to consider with this is how you're going to finish the outside of the building. So here you can kind of see we're still good as long as this point is 6 inches. I do like the other method over here better, but if you were going to finish this somehow, like let's say you wanted to have your siding or stucco go all the way across, and this might not be as big of a deal with stucco, but if you wanted to have your siding, you might not be able to nail it into the concrete here. This could be a problem. Something like this, you could finish this whole wall off with siding and even put some trim around the corner here, if that's the look that you want. I mean, the whole thing about planning all of this stuff is to actually take the time and consider as many possible problems or design issues while you're designing the building, and eliminate those after the fact. And of course, concrete, we all know, is unforgiving. You can't really just go in and say, oh man, I should have did this over here. And keep in mind that this is an example that you could use on both sides. And this is an example you could use on both sides. I just saved myself some recording time and drew both of them in here at once. You wouldn't build a house, I should say most of the time, where you have a situation like this and then a situation like this. It would be either one, this on both sides, or this on both sides. And of course, same here. If you were going to use this method here, you would put it on both sides and the solid concrete wall on both sides. Again, just throwing out some different ideas. This right here, we actually divided in half. If we were to measure the length of the top of the wall here, let's say it was 20 feet, this would be 10 feet. So this would be half. If you didn't want to split it up into 4 sections, you just wanted to split it up into 2 sections, it would look something like this. And again, the reason for doing this would be up to you. You know, I already provided you with the first examples, the one I would probably use for this, but you might have your reasons. Your architect might have the reasons for doing something like this. And even your contractor might have their own reasons. So again, the wall stopping here, If we were going to finish it with siding, maybe this would be the preferred method over this one here. And stucco might not be a big deal. And of course, you're probably going to want some anchor bolts to bolt this framing stud to the foundation. And if you're worried about, this is where I get a little creative in my framing, just to have a little block here and then have the wall finish over. No, use a piece of treated to as your top plate that you would normally have used construction standard lumber for. And, that way you got your treated lumber that's separating the framing lumber from the concrete. So just something like this be a good idea. And bolting everything together is nice. That's always a nice idea. So again, another method here. Now let's go ahead and take a look at our last method. This would be a solid concrete structure. And again, if this works for you, great. You're going to need an access hole in here. And I would imagine this would be the most expensive, but probably the strongest at the same time. And of course, your engineer might veto all of them. Your engineer might say, no, this is the only way that you can build something like this. We're not going to give you any other way. And that will be the end of that. So in this video, I will be providing you with a few ideas on how you can build a garage foundation on the side of a sloping hillside. And I will not be providing you with any structural engineering information. These are only examples for how something like this can be built. And another thing I will not be providing you with in this video, but I might make another video on that, will be how all of the structural rebar can be laid out for something like this. Now let's go ahead and start with the project completed, and then I will break it apart step by step and then put it back together. And this seems to be a pretty good way to teach people how to build stuff. So let's go ahead and get started by taking away the driveway and the garage slab, and then we will take a look at the fill dirt, or should I say fill soil. Now this would be an approved fill. I do not recommend that you fill this up with the dirt you dug out for the footings, because over time it could settle and provide you with a hollow spot underneath the garage slab. So keep that in mind when you're building your project. And now let's go ahead and take away the fill to give you an idea of what the soil might look like in here. Now keep in mind that you're not going to be shaping the soil like this. I did it as a way to make the design process a little easier and so that you could see the footings step down. But more than likely the inside of this is going to match the existing slope, with some exceptions to the area around the sides of the footings where you might need to shape them for a variety of different reasons. So keep that in mind when you're looking at this. Next up, we will be using some gravel that will go over a pipe that's going to have some holes in it to allow any water that gets behind the retaining wall here to drain through the gravel and into the pipe and then out of one of the walls and safely away from the building. Now keep in mind that this outlet for the perforated pipe can go at either end or located somewhere along the wall if it needs to be located in a different spot. Now let's go ahead and remove the stem walls so that we can take a better look at the footings and how they step down. Let's go ahead and remove the footing so that we can take a look at the soil. And I left the outline of the footing here again to give you a better idea of how the footing is going to step down. And now that you have a pretty good idea how to take it apart, let's go ahead and put it back together. And even though I am providing you with a view of the footings, it is going to be a lot better if you pour the footings and the stem walls at the same time. However, you are not going to be able to pour the footings, the stem wall, and the garage slab at the same time unless that's some type of a miracle. But again, I'm not going to count that out. If you can do it, that would be the best way. And let's go ahead and take a look at how I centered the stem wall over the footings. And in my example here, I'm using an 8-inch wide stem wall and 18-inch by 18-inch footings. So each one of these footings is going to be 18 inches wide and 18 inches deep. And to give you a better idea what that's going to look like, let's go ahead and take away the soil. Give you an idea of how the footings are shaped so that the rebar can come down and work its way all the way around the entire perimeter of the garage foundation. And that will also work inside of the stem walls also. Another view there. The other side. And I should also point out that I have extended the footing on this side only because there's going to be a lot of weight on this particular retaining wall. However, since I'm not an engineer, I'm not about to suggest that this needs to be done for this particular project, because the garage slab is going to be helping us tie all of these walls together and prevent them from moving, unlike a regular retaining wall that would be built by itself and it wouldn't have a bunch of rebar going through the walls into the concrete slab and tying everything together. Definitely something else to consider. Now let's go ahead and put the soil back in and then install the drain pipe. And even though I have the gravel running at an angle, you can always raise it up as you're backfilling to create a square or even a larger area. And again, this would depend upon a variety of different situations. Just like the additional footing on the front of this wall, you might need to put a little more gravel in here or even another pipe if these walls are going to be a little higher. And I don't think I mentioned that this front wall is 5 feet tall. So with that said, let's go ahead and put in our fill and pour our concrete slab for the garage. And I would imagine you could pour the slab and the driveway at the same time for something like this. And if you are going to be framing walls on top of the stem walls, then you might need some anchor bolts. And don't forget to make sure that your anchor bolts are installed at the right height. And don't forget to backfill all of the areas around the retaining walls. So let's go ahead and get started. Now I went ahead and formed it up. Now I don't have any braces on it, and the forms are just kind of freestanding. If this video, like I said, gets to 150 million views within the next 250,000 years, I will definitely do the best I can to make another video on how to form everything up. And with that said, and all joking aside, let's go ahead and just kind of take a look at what it would look like without the forms and without the center section that would be part of the slab for the garage floor. And of course, without the foundation walls, you would have rebar sticking out of the concrete. And the reason why I did this was to provide you with a couple of different ideas on how you could do it. And one of those would be to set all of the rebar and then pour the lower footings first. And then after that, it would make it easier to form the next section. However, I don't know if your engineer would like that, because most engineers are going to want to see this poured with the walls. And with that said, mentioning the engineer, keep in mind that I am not a structural engineer and that this layout might not work for your particular project. Next up, let's go ahead and remove the forms and then the concrete footing, and then take a look at the rebar, what it would look like on the bottom. And again, we got it bent at 45-degree angles basically. However, your angles might be a little different depending upon the slope on the hill. And here's an idea of what the rebar would look like in basically the area that's going to have the most weight against it because of the fill behind this particular wall. And here we can see how this rebar is bent and it's installed underneath the rebar that's going in this direction. And that will apply to all of the vertical rebar. It's going to need to go underneath these rebars. And I really don't know if something like this can be installed on top, because every time I see it, it's underneath the rebar that's going perpendicular to it. And we're just simply working our way up the wall. And I should also point out that the rebar needs to be at least 3 inches away from the bottom of the soil and the side. Wherever the concrete is going to be up against the dirt, you're going to need to have it at least 3 inches away. As we continue up here, give you an idea here, I just went ahead and ran this one in a different direction to go underneath the 2 horizontal rebars, and doing that just to get a little more strength out of it. And then a view there of the vertical rebar. And of course here we're underneath the front of the garage door opening. And of course the rebar's not going to be as tall here. Here's a view of it from the bottom. And then we will go ahead and take a view from the other side. And the rebar needs to lap. I'm using number 4 rebar here, and it needs to lap at least 20 inches or 40 times the diameter of the rebar. And I do have another video on that. You can always go to the website and then check out the building foundation section for a few more tips. So again, there's what it would look like if it was freestanding. Let's go ahead and put our forms in and then go ahead and fill it with soil and then continue our tour here. And again, since this is where most of the weight's going to be, we're going to need a little more structural strength on this than we will on the sides here, but that's not always going to be the case. Now here's what I said. If you went ahead and you poured this first and you had all the rebar sticking out, then it's going to be a lot easier because you can set the form boards for the next section on top. However, most engineers are going to want to see the footings and the walls poured at the same time to have a continuous pour to create a monolithic structure. And in case I didn't mention it, all of the rebar is spaced 16 inches on center, and that would be in all directions, going vertically and horizontally. And let's just go ahead and take a look at the top of it. And I don't really know if it matters if the rebar is on the front side or the back side, because I've seen it done both ways. And the longer lengths of rebar are going to be 20 foot long. And you can usually rent a rebar bender from your local rental yard. And the 1/2-inch rebar usually isn't that difficult to bend. Next up, let's go ahead and take a look at the inside form board that is a little lower. And it's lower because we're going to place the rebar on top of it that we will be using to connect all of the rebar we're going to put in the floor to these bars so that we can create a nice structural tie all the way around the entire garage slab. And the rebar that is going to connect to these pieces of rebar in both directions is what we're going to be using to hold the entire top perimeter together. And another thing I need to point out is that these rebars might need to be tied and connected before pouring the footings, because otherwise they're not going to be long enough. So for example, the engineer might have these going a little longer, and you don't want to end up pouring the footings and then jackhammering them apart because you didn't install the rebar deep enough. So again, I'm just kind of throwing that out there as another thing you need to think about when you're building this. And of course, another view. Let's go ahead and put our next form board on. And of course, this can be done differently. You could always have this as a solid piece and then drill holes for the rebar, or you can do it in 2 pieces, but you need to be thinking clearly on how you're going to take this thing apart after it's poured. And if you can come up with a better idea, then go for it, definitely. Now, something else I need to point out in the video that you need to consider will be the sloping garage floor slab. And in order for me to draw everything a little faster and make my job easier, I have everything level here. But that's only going to work for you if you have a level garage floor slab. However, if you have one that is sloping, you're also going to need to bring these rebars up to match the slope of the garage floor slab. Now let's go ahead and take a look at a view from underneath to see what's actually going to happen if you're not paying attention here and you end up having all of your rebar. So here at the front, we have them positioned right where they need to be, but as we go to the back of the slab, you can see where it's missing them entirely, and that is not what you want to have. And I wanted to provide you with one more view of the rebar without the forms, even though we're not going to be taking a tour of it. And let's not forget that we're going to need to block off the edge of the footings where the garage door opening is going to be located on both sides. Now, I also need to point out that this rebar is going to be a little higher than the top of the wall here. And that's because the garage slab is going to be poured over this area. And I also don't recommend smooth finishing this section right here, because the rough surface is going to provide a better bond for the concrete floor once we pour it on top of that area. And of course, I can't forget the anchor bolts, even though I'm not going to be providing you with layout instructions on that. But you are going to need them if you're going to be framing walls on top of your new stem walls. And of course, let's go ahead and take the upper form board off to give you a better idea how this construction method is going to work. Next up, let's go ahead and strip the rest of the forms off so that we can get a look at what the walls and the rebar will look like before we add our fill, so that we can get everything ready to pour the garage floor slab. And of course, after you have everything compacted and ready to go, you can go ahead and install the rebar. And this should give you a good idea how we're going to use the rebar to connect to each side of the wall in both directions to create a nice structural tie between these walls and prevent them from moving. And of course, this is going to be one of the most important parts of the project. And here's a view of the rebar, how it's going to connect to the angled bars over the garage door opening, and how it will connect to these bars. Now you need to make sure that this is at least the minimum distance for lapping, and to provide you with a little bit of insurance, it wouldn't be a bad idea to make this part 30 inches or even a little longer, because the last thing you want to do will to have something like this a little too short, and then you have a big problem. However, that's not going to be you, because you're paying attention to most of the information in this video. And if you have a set of building plans, you followed everything on those building plans, and now it's time to pour the finished slab. And of course, that brings us to the end of the video. And again, I would like to point out that your project might require different layout, different sized rebar, and even additional rebar, especially in this area down here. So with that said, if you learned something or enjoyed the video, hit the thumbs up button. And if you have any questions or comments, leave them in the comment area and I will answer them as soon as possible.